Hi everyone, and welcome to Astronomy. My name is Kalei Tak, and I'm one of the two astronomy instructors for OHS this fall. My background is actually in chemistry. I did my undergrad at Harvard and then came here to Stanford for a master's in physical chemistry, which I followed with a master's in education. I've taught for the Princeton Review, the medical college admission test, physics and chemistry sections, and also for various robotics programs at schools in my area. And I love to do hands-on science, as you can see on the slide. I also love hiking and biking and hanging out with my family, which consists of my husband Theron and my 3 children. And here to introduce himself is my awesome co-instructor, Chris Oparko.
What's up, everybody? I'm Chris Oparko. So I'll tell a little bit about myself. I am a California resident. I've grown up in the Bay Area and then went to Sacramento area a little bit for my high school years. And I'm back in the Bay Area. I did my undergraduate at Santa Clara University, where I pursued physics and mathematics, or I love very much, but I decided to pursue physics as my kind of end goal there. So I went to University of California, Davis, where I specifically focus on cosmology. So similar to astrophysics, but we can talk about that later. And so at both schools, I did some research. At Santa Clara, I worked on solar cells. And so we did a little bit more engineering perspective on that side. And so as my graduate degree, I worked in cosmology. I did more research in galaxy lensing. And so we can talk about all of that later on as you have questions, and I can explain how much I love about it and, a little bit what I got out of my research. A little bit more about myself, not in the academic sense. I love sports. I played soccer, I played wrestling, ran track, and I still continue to try to run now and play soccer. I also love baking. I have myself a KitchenAid mixer where I try to mix up all these kind of things and bake cookies and cupcakes and all this kind of mixture of things. And more recently, I got along with gardening. So I moved into a new place and try to renovate the little front yard. So I'm trying to learn more about flowers and what I can do to not kill them. So I'm trying to get that green thumb. And also, I like sewing. That's the last little thing right there. So I would love to get to meet all of you just as much as you get to know about me. So hopefully we have a great and awesome year. I can't wait to get started. All right.
A typical week in astronomy for us is going to involve reading or video questions, which are due on Sundays at 6 p.m. This is to get you acquainted with the topics we'll be covering in section during the week. So you'll actually be writing out your answers to those reading questions and turning them in as a document on Canvas. Then in class, we'll deepen our understanding of the topics through discussion and various activities. And at the end of the second section of the week, we will assess your mastery of the topics with an in-class quiz. We'll also do a lab every week in which we practice our scientific communication skills and deepen our mastery of the topics further. If you've taken other classes with me, labs for astronomy are less writing intensive than those you may have encountered in the past. There's more of an emphasis on calculation and understanding of the topics for astronomy. You'll have the option of doing quiz corrections, and also each week you'll need to participate in section to engage with each other and with the scientific topics. What are those topics? Well, we'll start with the night sky and how we locate objects in the night sky, including stars and also the moon. On the slide, you can see a crescent moon. I'll teach you not only how to tell the phases of the moon, but how to look up at the moon and from its phase and position in the sky, infer what time it is at night. So that'll be a little more than maybe you've learned about phases of the moon in the past. We'll talk about the stars and how over the course of the night, the stars appear to sweep out circles on the sky, all centered on the North Star Polaris. And we'll delve into the history of astronomy, thinking about how the realm of the eternal, the perfect and unchanging world of the stars used to be separated by crystalline spheres from the realm of generation and corruption on Earth. And we'll talk about what shattered those crystalline spheres in the history of astronomy and how that happened. We'll talk about Kepler and his orbits, the man, and now a space telescope, bringing us back useful data from the heavens. And then we'll discuss the mysteries of dark matter, what it is, why we think it's there, how we think it operates, and how it affects the rotation speeds of various galaxies. Following that, we'll move from the darkness into the light. We'll talk about filters and how they're used on telescopes to get valuable information about extrasolar planets and other objects in the night sky. And if you're not already able to decipher the message on this slide, you will be after our study of filters in astronomy. But different wavelengths of light are one way to figure important things out about what's going on. Another way is dips in starlight. Tiny little dips in starlight can allow us to infer the presence of a planet orbiting the star. Consider this night skyline viewed from out on the water and imagine that one person in one building closes one window halfway. That's how tiny the dip in starlight might be for us to infer a planet. We'll talk about how that works and how we can figure out what's going on with those orbits. We'll talk about Star Wars and Tatooine worlds and why they're actually pretty realistic to imagine a planet with two suns. Of course, Star Wars also had some less realistic elements as shown in these two images on the slide at the bottom, and we'll talk about why those two images are both somewhat unrealistic. We'll delve into astrobiology because, after all, the reason we're interested in planets outside our own solar system is because of the possibility of life on those planets. And we'll discuss why NASA's motto is follow the water in looking for extraterrestrial life, and what's so important about cell membranes that causes us to get really excited when we find evidence of either water or cell membranes out in the cosmos. Speaking of the cosmos, we'll zoom out and look at our solar system, why Earth is in such a perfect place for life to exist upon it, and why all the planets in the solar system orbit in the same plane. Has that ever given you pause? It will no longer after our unit. On that, we'll talk about the stars, their lives, and their spectacular deaths, and how they evolve over time, and how we know what we know about the lives of the stars. And we'll follow that with a unit on black holes, with two guest lectures by Dr. Gary Oas, the glorious ruler of all space-time. Are you ready for astronomy? I'm ready for astronomy. In the words of Captain James Kirk. Thank you.